Okay, let's unpack this. You've brought us some absolutely fascinating material about something we all do, but is, well, incredibly complex, learning words.
That's right.
Today, we're taking a deep dive into your sources on early word learning, really zeroing in on that foundational challenge.
Right.
Figuring out what those bursts of sound around you actually refer to in the world.
Think of this deep dive as your shortcut to understanding the surprising mental hoops involved in building a vocabulary basically from scratch.
Right.
We're here to guide you through this material, highlighting the crucial insights and maybe some unexpected findings.
Our mission, to help you see just how much is hiding beneath the surface of seemingly simple acts like pointing and naming. So drawing from these sources, where do we even begin when we talk about a word? What is it, fundamentally?
Well, at its core, a word is described as an arbitrary pairing of form, like the sound you hear, and meaning. It's that combination.
Right, and the key there is arbitrary. I mean, there's no inherent reason why the sound chair connects to that thing you sit on. Because of that, these pairings, what the sources call lismums, they have to be learned, right?
Yeah,
And stored in memory.
precisely. So for a young learner encountering a word, there are two main things they need to figure out. First, the properties of the form itself.
Like identifying the sounds, finding where one word ends and the next begins in speech.
Understanding stress patterns, all that stuff. Yeah.
Which, as the sources wisely note, is a huge challenge all its own. They point to work by Safran, Gout, Shukla for more on that. But that's not today's deep dive.
Correct. Our focus today is the second part, figuring out the properties of the meaning. What concept does this sound linked to? How is the word used?
And just to scope this out, the material hones in specifically on how children learn words for like medium-sized, everyday, concrete objects, that kind of thing.
Yes, we're looking at learning with sources called prosodic words. These often roughly correspond to roots in languages where words often stand alone, the kind of words you can often point to.
So we are deliberately not getting into the much later challenge of learning abstract words like the or most, or even today.
Definitely a separate deep dive, maybe for another time.
Yeah.
Focusing on these concrete words lets us confront some of the most fundamental problems, connecting language sounds to the physical world.
And this takes us right to a core idea mentioned early on, that learning, well, at its heart, it looks like hypothesis testing. Fodor makes this point.
Yeah, imagine trying to figure out what a new word means.
Yeah.
Let's say miv. If you see something red and round labeled miv,
Okay.
you might form the hypothesis, okay, miv means red and round. Classical learning theories suggest you then test this hypothesis against incoming data.
The data, the input from the world around you, helps you figure out which of your possible hypotheses is most likely correct.
Right. If everything labeled miv is red and round, that hypothesis gets stronger. Seems simple enough.
But here's where it gets really interesting, and something the sources highlight as a core puzzle. This model kind of presupposes you already have a space of possible hypotheses to test.
Exactly. Red and round, spherical, shiny, whatever. Where do those hypotheses come from? How does the learner even generate the candidates for meaning in the first place? That's a deep question.
And that question, what counts as a possible meaning, leads us to ask, what are word meanings anyway? Are they just simple definitions?
Well, the sources use the example of chair. A dictionary might say, a seat with a back and four legs for one person. Sounds straightforward, right?
Seems okay. But then you think about the tricky cases they mention. Like, what about chairs sculpted into stone, part of the architecture? Are those chairs?
Or seats in another culture designed for two people but with seven legs. Are they chairs? It gets fuzzy.
These examples really challenge simple, rigid definitions, don't they?
They do. Whatever the meaning of chair is in our minds, it seems to have a flexibility that goes beyond just a strict list of features.
This is why the sources distinguish between extensions and intensions. The extension of chair, that's a set of all the actual chairs out there in the world.
Right, all the real ones. But the intention is the underlying concept of chair. And this concept is crucial because it lets us think and talk not just about the chairs we've seen,
but also hypothetical ones or possible chairs like those stone ones or the seven-legged ones.
Exactly. So meanings aren't just lists of properties or collections of real objects. The sources briefly touch on other ideas too, like prototype theory.
Where you have a typical chair and judge others based on similarity.
Yeah, or even ideas from philosophers like Hume or maybe Prince, suggesting meanings are just systems of association between sensory experiences.
But however you define the meaning, the problem of getting from the sound chair to that concept or set of features, that remains.
Absolutely.
The most intuitive idea is probably simple associative learning through observation. You see a dog, you hear dog, you make a link.
Right, the sources give a nice example from Bloom. A toddler chasing a dog, the mother says dog, maybe points.
And the child tries to imitate. Seems straightforward.
And, while most researchers agree observation plays a role, the critical question is still, what innate abilities, what starter package of biases or strategies does an infant need to actually do that successfully?
This brings us back to what the sources call the POS problem, the problem of origin. If meanings are abstract concepts like intentions,
Yeah.
how does a child bridge that gap from a fleeting perceptual experience seeing that specific dog right now to something qualitatively different, the abstract concept DOG that applies to all dogs, past, present, future dogs?
Exactly.
Yeah.
The origin of these abstract concepts is a deep puzzle. And even if you argued meanings were just about grouping perceptually similar things,
Okay.
you still face the problem. How does the child know which perceptual features are the relevant ones for grouping? Is it the fur, the shape, the bark? Where does that knowledge come from?
And even when there's a clear, concrete thing right there, Quine's famous Gavagai example shows observation alone is still incredibly ambiguous.
Aye, yes, Quine. He imagined a linguist encountering an unknown language speaker. A rabbit scurries by, the speaker points and says, Gavagai.
What could Gavagai possibly mean? Seems simple. Rabbit, right?
You'd think. But, as the sources point out, it could mean rabbit ear, dinner, animal, thing that hops, maybe undetached rabbit parts.
Or even something bizarre like a rabbit only until 2021. That's wild.
It illustrates the fundamental challenge a child faces constantly. Even when a parent says, look, a doggy, and there's a dog right there, the input doesn't isolate exactly what aspect of the scene is being labeled.
So in principle, there's an infinite number of potential hypotheses.
Exactly. The input isn't specific enough.
Yet children do figure this out, and astonishingly early. According to some work mentioned, maybe even some mapping by 6 months, how on earth do they cut through all that ambiguity?
Well, the sources lay out several proposed solutions. One is what's called a pragmatic solution.
Pragmatic. Meaning?
It suggests the answer lies partly in the nature of human communication itself.
Mm-hmm.
We're generally cooperative, right? We share ideas about being informative.
Okay, so when a parent labels something for a child, they're probably trying to be helpful.
Probably. They're likely to label the whole object, the rabbit, not just its ear, because that's usually the most informative thing in that situation. There's a kind of implicit agreement on a scale of specificity.
Interesting. So relying on the speaker being helpful, what else?
Beyond that, the material also discusses the role of innate learning biases, things inside the child's mind that help constrain the possibilities.
Biases like mutual exclusivity, the idea that each thing only gets one name.
That's a big one. Or a bias to favor newness, maybe.
And powerful biases towards basic level categories, like labeling something dog rather than the superordinate animal or the subordinate poodle.
Exactly. And a bias towards whole objects over their parts or properties seems really important early on.
And interestingly, the sources note that the specific cues children attend to might differ for different types of objects.
Right. Like shape seems particularly important for artifacts, things people make. But for animals, maybe shape, color, and texture matter more.
Okay, so biases help narrow things down. What else?
Another major proposed solution to Quine's problem is cross-situational learning, or CSL.
Cross-situational learning.
The core idea here is that you don't need to figure out the meaning from just one ambiguous encounter.
Okay, so not just Gavagai once.
No. Instead, you track co-occurrence statistics across many situations. If you hear ball, when there's a ball, a block, and a car, and then later hear ball when there's a ball, a book, and a doll. Only the ball is present in both instances.
Ah, I see. So over time, by tracking these statistical regularities, you can zero in on the correct referent.
That's the idea, and there's some exciting empirical evidence for this. The Smith and Hughes study from 2007.
With the preferential-looking paradigm?
It's exactly. With 12 to 14-month-olds. They showed infants' scenes with multiple novel shapes paired with novel words. At test, infants looked longer at the shape that had consistently co-occurred with a given word.
Wow. So that showed they can track these statistics across situations. They have that ability.
It was pretty groundbreaking, yeah. It demonstrated that young infants have this kind of statistical learning ability in their toolkit.
But the sources also point out a conceptual issue, right? If word meanings are abstract concepts, not just lists of reference.
Right. Then CSL might be more about accumulating evidence for abstract hypotheses,
Hmm.
rather than just finding correlations between words and objects. The POS problem again.
And there are also some, well, empirical challenges for CSL as the complete explanation.
Yes, definitely. Like the phenomenon of fast mapping or one-shot learning.
Ah, the Carey and Bartlett chromium study.
That's the classic example. 3-year-olds learn something about the color chromium after hearing it just once in contrast with a known color. Bring me the chromium one, not the blue one.
And they remembered it later.
Retain that knowledge a week later. Yeah,
Yeah.
one shot.
And what about this study on blind children, Landau and Gleitman?
Another fascinating piece. Blind children acquire language remarkably similarly to sighted children. Their early vocabulary is comparable, focusing on concrete things they can touch or interact with.
So visual observation isn't the only route to word meaning. Maybe not even the most fundamental for some words.
It strongly suggests that yes, or that the crucial information isn't purely visual.
These cases feel like they might challenge a theory that relies solely on, visual co-occurrence statistics across lots and lots of trials.
They certainly raise questions, but perhaps an even more fundamental challenge to standard CSL, raised by the sources, is about memory load.
Ah, right. Can learners actually remember the details of multiple ambiguous situations well enough to compute those cross-situational statistics?
Exactly. And this is where findings from studies like Truswell et al.,
Mhm.
2013, Woodard et al., 2016, and Aravind et al., 2017, get really interesting.
What did they find?
They suggest that both adults and children might actually struggle to track information across multiple instances simultaneously, at least in the way CSL traditionally assumes.
Really? Even adults?
In the Truswell et al. Adult study, participants learned novel words presented with multiple objects over 5 learning trials. They showed gradual learning, sure, but their success on any given trial was only predicted by the immediately preceding trial.
Only the one just before, not 2 or 3 trials back.
Apparently not. They didn't seem to benefit from information further back. It suggests a very local process.
Wow. So it wasn't like they were holding a list of possibilities in their head across all 5 situations. It was much more immediate.
Yeah, the sources conclude from this that learners seem to struggle to maintain multiple candidate meanings across distant learning instances. The memory constraints seem quite tight.
And the other studies found similar limits in kids.
Woodard et al.
Yeah.
And Aravind et al. Found similar limitations in children's ability to track information across multiple trials in the way a standard CSL model would predict.
This raises a huge question then. If learners can't effectively remember and compare possibilities across several trials, how could cross-situational learning work? At least not in the broad sense it was first conceived.
This led some researchers to propose an alternative strategy called Propose But Verify, or PBV.
Okay, propose but verify. How does that work differently?
Well, instead of trying to track possibilities across all previous trials, the learner makes a single guess about the word's meaning based on the current context, or just one hypothesis.
Okay, one guess, then what happens with it?
They carry that single guess forward and test it against the next time they hear the word.
Ah, okay. So compare it to the next instance only.
Right. If the guess is consistent with the next situation, great. They reinforce that meaning.
And if it's inconsistent, if the guess doesn't work next time,
Then they abandon that interpretation entirely. Just drop it. And make a new guess based on the new context, which then gets carried forward to the next encounter.
that sounds like it requires a lot less memory than CSL, right? You're only holding on to one guess at a time.
Precisely. The sources note that PBV is less cognitively demanding in terms of memory. Much simpler.
But is it less reliable? What if your first guess is just wrong?
That's the trade-off. It's less fail-safe. If your first guess is wrong, you completely discard it and have to start over learning that word. With ideal CSL, even if one trial is misleading, the statistics across many trials should eventually win out.
So PBV works best if the learner is pretty good at making a correct guess, or at least a reasonable one, on the first try.
Exactly. The quality of that initial proposal becomes really important.
So what kind of evidence helps make that crucial first guess a good one? Where do good first guesses come from?
This brings us to something called the human simulation paradigm, or HSP, pioneered by Snedeker, Gleitman, and Brent, and replicated later.
What did they do in that paradigm?
They had adults watch silent videos of parents interacting with their children. The adults would hear a beep when the parent said a target word, and they just had to guess what word was said.
Just from the silent video and a beep, that sounds incredibly difficult.
It was. Accuracy was generally pretty low, maybe around 15% overall. But what really stood out was that nouns were much easier for adults to identify than verbs in these silent videos.
Nouns easier than verbs. And that connects with what we know about children's early vocabularies, doesn't it? That well-documented preponderance of nouns.
Absolutely. Children's first 50 words or so are packed with concrete things.
Yeah.
People, food, body parts, toys, mostly nouns in English.
And this isn't just an English thing, right?
No, a large-scale analysis by Brzezinski and colleagues across multiple languages confirmed that early vocabularies are heavily skewed towards nouns, or perhaps more accurately, towards words for concrete things.
So, what makes nouns or these concrete words easier to guess just from observation? Did the HSP studies shed light on that?
Yes, Truswell and colleagues did a corpus study analyzing those HSP videos to find what they called referential gems.
Referential gems. I like that. What are they?
These were moments, specific video clips, where adults were reliably able to guess the target word, much better than average.
Okay. And how common were these gems?
Only about 7% of the videos qualified, meaning more than half the adults could guess the word correctly just from the scene. And significantly, all of these gems were nouns. Every single one.
Wow, all nouns. What characterized these magical moments? What made them so clear?
Several cues seemed to align pretty powerfully. The target object was usually present and often appeared immediately before the word was spoken.
Timing is key.
Seems so. There was also often increased attention from both the parent and the child towards that target object before the word, like they were both looking at it.
Joint attention.
Exactly.
Yeah.
And parents were more likely to gesture towards or physically present the object right around that time.
Holding it up, pointing.
Yeah. And crucially, there was often decreased attention to other non-target objects around the time the word was spoken. So the focus was really narrowed.
Makes sense. All these cues together create a highly constrained, clear situation where the intended referent of a concrete word is just very, very salient.
Right. These referential gems provide strong support for how learners might make good initial guesses for concrete words. And under a PBV framework, that could be very efficient.
But the sources wisely add an important caveat here. These powerful cues work best for concrete objects, right? They kind of presuppose something you can point to or focus attention on.
Yes, that's a critical point. The apparent ease of learning nouns might be a bit of an Anglocentric bias, or at least an artifact of English structure. The real factor is likely concreteness.
Which often aligns with nouns in English, but might align with other grammatical categories in languages that structure things differently.
Precisely. Gentner and Gleitman have talked about this.
Okay, so that raises the next big hurdle. If observation cues and these referential gems are great for concrete nouns, how do children learn verbs? Or more abstract words where those kinds of clear, point-to-able situations are rare?
This is where we encounter Leela Gleitman's really powerful idea of syntactic bootstrapping.
Syntactic bootstrapping. Okay.
The hypothesis is that the child's early vocabulary, which is heavily concrete and nominal, provides the leverage, the bootstrap, to start figuring out the structure of their language, the syntax.
So the known words, the nouns they learn early, become seed words that help unlock the grammar.
That's the core idea. With a basic set of known nouns, the child starts hearing them in sentences. If you know mommy and ball, and you hear mommy kick the ball while seeing the action.
Your known nouns might help you infer that English uses a subject-verb-object-word order.
Exactly. Or if you hear the ball, knowing ball is a noun, might tell you something about how articles like de combine with the noun phrases. You start learning the patterns.
So the idea of syntactic bootstrapping is that if word-to-world mapping is ambiguous for abstract words, like verbs,
Yeah, which it often is.
then sentence-to-word mapping can still provide crucial clues. The sentence structure itself acts like a mental zoom lens.
That's a great way to put it. It highlights the aspects of the scene or event the speaker is describing. The sources suggest there are principled connections between grammatical structures.
Like the specific sentence frames verbs appear in, subcategorization frames.
Right. Connections between those frames and abstract semantic concepts like cause or transfer or motion. Learning these links provides vital information about verb meanings that you just can't get from looking alone.
Is there good evidence for this, for syntactic bootstrapping?
Yes, there's compelling evidence, including from adults. The Snedeker and Gleitman study from 2004 is a key one.
What did they do there?
They compared adults trying to learn new verb meanings based on different kinds of input. Some just saw the scenes, videos of actions. Some knew the nouns involved in the sentence. Some only got the syntactic frames like she, was, him, the re, with nonsense words.
Okay, different types of clues.
Yeah.
And what did they find?
Well, learning the verbs was possible with each type of information, which is interesting in itself. But here's the really critical part. Using the syntactic frames alone was about as effective as using the scenes plus the nouns.
Wow, so just the sentence structure was just as informative as seeing the action and knowing who or what was involved.
For adults, in that task, pretty much, yes. The structure carried a lot of weight. And, not surprisingly, combining all the information, scenes, nouns, and frames was the most effective way to learn the verb meanings. Best performance overall.
The takeaway seems to be that learning abstract words, especially verbs, isn't impossible once you've given linguistic context, like a basic nominal vocabulary and some grasp of sentence structure.
Right, alongside informative situational cues, you need both, probably.
So the early concrete vocabulary bootstraps the syntax.
And then the syntax helps bootstrap the meaning of less concrete words. It's a really powerful hypothesis for moving beyond those initial referential gems.
Of course, as the sources point out, a full theory of syntactic bootstrapping still needs to spell out exactly what those fundamental bootstraps are. You know, the basic syntactic and semantic primitives and how they map onto each other. That's still ongoing work.
Absolutely. But the material you shared provides a wealth of starting points and further readings mentioned in the sources for diving deeper into the evidence for children using syntax to learn verb meanings.
Like lids, Fisher, Yuan.
Exactly.
Yeah.
And how syntax helps with other content words, too. And yes, Fodor's Concepts Chapter 3 is flagged as a fun, optional read for thinking more about what concepts themselves even are.
So we started with something that looks so simple, a parent pointing to a dog and saying the word dog.
Yeah, seems trivial.
And we've taken quite a journey, a deep dive through the incredible complexity involved.
We really have. We've journeyed through the ambiguity captured by Gavagai, explored hypothesis spaces, debated memory strategies like cross-situational learning versus propose but verify.
Uncovered the power of specific cues in those referential gem moments for concrete words.
And discussed the really ingenious idea that learning nouns might provide the key to unlocking the grammar needed to learn verbs. Syntactic bootstrapping.
You've seen how word learning is far, far from simple association. It's a sophisticated process involving, well, innate biases, statistical tracking, even it's very local, strategic guessing based on helpful cues, and using linguistic structure itself as a guide.
It's much more intricate and, frankly, amazing than it looks on the surface.
And this whole deep dive leaves us with a pretty fascinating question for you to ponder. Given how uncertain pure observation can be for pinning down word meanings, and how much seems to rely on either internal biases or knowledge gained from other words and grammatical structures, what does this tell us about the powerful cognitive machinery, the tools an infant must possess before they've even learned very many words at all? What's already there?